Hello, I'm Jonathan. I will tell you something about Softbound in a couple of minutes. Bedi Tresor will tell you something about sets. First, I'm going to repeat the different types of memory safety. Spatial memory safety, which protect pointers from reading or writing data outside the object. This can be buffer overflows, overwriting the return address, and so on. Secondly, temporal memory safety will protect for reading or writing to objects that no longer exist. They are also referred to as dwelling pointers. Softbound is a tool to enforce spatial safety. This happens by compile-time transformations of the C code. Extra code is asserted at runtime for the checking of the pointer bounds. This happens by a pointer-based approach, but I'll tell something about that later. Softbound can be run with two modes. The first is the full checking mode, which is used for security critical applications. This offers spatial safety, but comes with an overhead of 67% at runtime. Store-only checking mode, on the other hand, is used for low overhead debugging, and now there's only an overhead of 22%. But this comes at a disadvantage. There is only checked for out-of-bound writes. This can, however, stop most security vulnerabilities, since they require at least one write operation. I'm now going to explain some other terms. The first is sub-object overflow. Like it can be seen in the example, this means that a buffer that is part of another object will be overflowed. Another term is the object-based approach. This means that all allocated regions are tracked in a different data structure. These map any locations inside the region to the bounds of the object. For the pointer manipulations, it is checked that they are still within these bounds. This information is tracked per object, so every pointer to the object shares the same bound information. The advantages of the object-based approach are that the memory layout of the objects are unchanged, which improves the source and binary compatibility. Secondly, all memory heap allocations update the object lookup data structure, which allows every valid pointer to be mapped to an object. Now for the disadvantages. They require special out-of-bounds proxies. Secondly, the object lookup is a range lookup. This means that the pointer in the object must correctly map to the object's bound information. The last disadvantage is that all the implementations are incomplete, which means there is no guarantee that all spatial violations will be detected. Pointer-based approach will track base and bound information with each pointer instead of the object. So two distinct pointers can point to the same object with each a different base and bound data. The advantage over the object-based approach is that complete spatial safety can be enforced. The disadvantages are, however, that checking this for each pointer leads to runtime overhead and the memory layout is changed. Now I will show with a few examples of changes Softbound makes to the code to achieve spatial safety. In the examples is the black code the original provided by the programmer, the red code is added by Softbound. The first change is the pointer dereference check. To do this, a check method is created to validate if the pointer is valid within the base and bound values. This method is then called every time before a pointer value is used. In these two examples, it can be seen that when creating a pointer, extra code will be added to also create base and bound information of that pointer. In the first example, it can be seen that for a pointer arithmetic code is added for the creation of base and bound data. The second example shows this also happens when a value is assigned to the pointer. Structure field access is a combination of the previously discussed techniques. So first, the base and bound information will be calculated for newly created pointers as well as for pointer arithmetics and assignments. These last two are still allowed to go out of bounds at the assignment of the pointer value, because afterwards the pointer dereference check will check if the value is valid or not. Softbound now onto pointer bounds when a pointer to a field in a struct is used. On this way, sub-object overflows are prevented. However, this cannot be always used. For example, when a program attempts to operate on 3 consecutive fields of the same type, or a pointer to an item of an array is referenced, since this is sometimes used to indicate a subset, both cases will generate false positives. The previous transformations only handled pointers as values that can be mapped to registers, but as pointers must also be stored and retrieved from the memory, a table structure is added to map the addresses of the pointer in the memory to the corresponding base and bound information. So Softbound also adds a table lookup when a pointer value is used and insert a table entry for every store of a pointer. This affects only the operations of pointers, the one on non-pointer values are unaffected. When pointers are passed as an argument to a function, the base and bound information of that pointer must be known within this function. To make this possible, the function calls are rewritten so this data is also added in a call. The name of the function is also appended with the unique softbound identifier. On this way it is known that the function is modified. Functions that return a pointer are modified to return the tree value. From the comparison to related approaches, it can be seen that object-based approaches generate higher overhead than the softbound solution. This overhead is on average 12, 24 or 7 times higher depending on the used compiler.